All right, welcome everybody back to the last ABYC Thursday webinar of 2020. I think we're all pretty excited to see 2020 be over. So we do have one more in this series that's going to be up in January that we'll talk about, but we will start a new series after that. So don't worry, these aren't going anywhere. First off, I want to thank Nancy Frainetti and DeBoy, who are on the screen here. They'll introduce themselves a little more when they take over here on the presentation, but as always, got a couple things to go through. First off, we want to thank our sponsors, Jasper Rural Xylem, Safe Harbor, VETUS MAXWELL, and SAM, Society of Pacific Marine Surveyors. Nancy, can you mute your mic for a sec? I got a little bit of feedback there, if you don't mind. Thank you. All right, normal updates. Save the date for our standards week. I know Chris attended our standards week before and a lot of other people have. It's virtual this year, so there's a lot of great stuff going on. Our annual meeting, I know everyone's used to coming and having some drinks with us, but unfortunately that's going to be digital too. So here's kind of a rundown of the week we have. We have our annual meeting and happy hour January 5th. Our PTC meetings are meeting January 11th or the 21st. So feel free to attend any of those. Our SurTech event, which I'll touch on, January 6th and 7th. And we do have a standards course at the end of the month there too. So as always, our webinars are open to members first. So thank you guys for attending. And topics, we're always looking for new topics. We're thinking probably March we'll start back up with a new series of these. So any topics you'd like to see, please let me know. Kind of a last call for our foundation fan. All the proceeds will support the ABYC Foundation. So if you want to be in the background of our annual meeting and our SurTech event, let us know, shoot us an email, even if you don't have a picture ready for us. We'd love to see you there. We got a great little group already, as you can see, ready to attend, if you will. Our SurTech event, it's a surveyor and technician event. We have a lot of great topics being covered between electrical and everything else in between. So if you're interested in that, you do get 10 CEUs for that. So take a look at abycsurtech.com for more info on that. And our online classes, as always, we're continuing those. They're working well. We don't plan on having any in-person classes as of now until we're looking at possibly June as the first date for that. So that's obviously going to change with everything going on, but just if you're looking for an in-person class, the next time we'll do that. But we do have plenty of online classes scheduled through April. So if you're interested, take a look at those. CEUs, once again, we do give CEUs for these. If you are watching this live, you will get a link in your email that you'll receive tomorrow, an automated email to apply for those. So all you got to do is log in, answer the quick question, which is checking the block that you attended, and credit will go to your transcript. If you have any questions about that, you can email education@abycinc.org. And any questions you have during the presentation, there's a little question box. So fill that out. Whatever time that allows at the end, I will be reading those questions off as always to our presenters there, and they'll answer them the best they can for you. Lastly, before I turn it over to Nancy, our next webinar, which is the last of the series, will be January 28th. So we got a little gap here, but it's going to be a good one where we talk about lithium-ion technology. So with that, I am going to turn presenting mode over to Nancy, and we'll get rolling here.
Okay.
All right, I'm going to drop myself off camera here.
Okay. Okay, now. Well,
not seeing your screen yet, I don't think.
Oh, okay. So that's odd because. Uh-oh.
Should be a little screen share button, maybe a plus sign.
Oh dear.
It's technology, it happens.
I know.
Oh, there you go.
Okay. Excellent. Now I can't see my screen though.
You can drop off your camera too, Nancy, and that'll make it a little easier.
Okay. Well, before I do that, I would like to say hello everyone. I'm Nancy Frainetti, also known as the Electric Boat Lady for many years. I believe that's because a lot of vowels in my Italian surname that people have a little struggle with, but nevertheless, I answer to both. And I just want to say it's a pleasure to be here today to take part in this webinar, along with my colleague and friend, DeBoy. So I'm going to say goodbye and let's get to my slideshow. Sorry. Oops.
Good to go. Oh, you're back on camera now. Now you're good.
Okay, that is not my slide. Okay, here we go. All right, very good. Okay, so if I may begin, I would like to start with a review of my 20+ year career as the electric boat lady. So I began in 1998 as the Florida rep for Duffy Electric Boats. And I will say, knowing very little about electric boats, other than my youthful years, we had a cottage on a combustion restricted lake in Pennsylvania, whereby I proudly had a John boat with a prehistoric trolling motor and one of those big black acid spewing car batteries as my propulsion, my first electric propulsion back in the 60s, I might say. So I started the first electric boat rental in downtown St. Petersburg. Then followed that up with co-designing a 24-foot electric launch, which I then designed or redesigned and repowered with in 2014 with Island Packet Yachts. Okay, and I'm all sorry. Oh dear, why did that advance? There we go. Sorry, I don't know why is that doing that. Uh-oh. Darn technology. Okay. Oh, I'm really, I don't understand why I mean, I'm gonna just pause it. Yeah. Anyway, you really need to see that screen. David, can you help me?
Which one are you looking to see here?
That one. I want it to stay, but it won't stay.
You must be something in PowerPoint for some reason. So yeah, that's.
I did it so I could advance it myself.
Mhm.
Let's see if I put it there. Okay. Well, it's really important that you see this. So darn it.
You can exit out of a presenter mode and it should just show it on the screen. That might help a little bit.
Okay. Is that good? Can you see that?
Yep. No, you unshared the screen, so you gotta reshare that, and then yeah, it's something in PowerPoint. So there you're good now.
Okay, let's do this. Okay, so I'm the founder of the Electric Marina, but now it's owned by Cecilia Potts, whom, by the way, she's doing a fabulous job of elevating the business to a new successful tier, and I am very grateful for my Cecilia, or Seal, as we all refer to her as her nickname. Anyway, okay, so also pictured on this slide are some of my enjoyable career mentions. I was a design team member on a very unique electric assist pedal boat project. And then as you see on the bottom there, my excitement in being able to sea trial one of the first Torqeedo deep blue outboards. That was a fun day for me. And then I was contracted by Ripley's, believe it or not, to repower their wooden Ferrari boat from diesel to electric. So I'd like a show of hands, if I may, who has that one on their resume? I do. But okay, so let's go to our next. In 2015, I did a 360-mile fundraiser voyage from Miami Beach to Jacksonville in one of my Island Packet electric launches, along with my sister Paula, and we did this to benefit a small breast cancer foundation in Jacksonville. And then where I am today, I'm proudly heading the Electric Marine Power Department for Yanmar Mastry Engine Center in St. Petersburg, Florida. I have to have a side note here. Most business people start out in the corporate world and then they become an entrepreneur. Well, I did the complete opposite, but I couldn't be happier. So I'm very fond of my Yanmar Mastry engine center. Okay, so one thing's for sure, I'm really glad that my career did not begin in the 19th century where electric propulsion originated, but rather in the 20th and 21st centuries. Yay for technology. Okay, and darn it, this is going. Okay. Okay, along with the ever advanced, oh no, sorry, I'm confused now. Sorry, this is really bad. Okay. I want it to stop. Okay. So along with like the ever advancing battery technology, chemistry, smart chargers, and alternative charging options, you know, that I'm also grateful, you know, that is happening. But also, I'd be remiss if I didn't give a gratitude shout out to the electric auto industry that led the front for enlightenment, acceptance, and what I truly believe encouraged boaters to think, you know, the same, to repower their boats. So yay to Elon Musk and everyone else. Okay, so this slide is where I want to be because we can all see that there definitely are a lot of new players in this coming to age industry. However, I am going to do, my presentation today is going to be focused more on the motors that I'm familiar with and that have been marketing for throughout these last 20 years. But before I proceed, I think it's fair to give credit to where credit is due for this motor collage. Okay, and that goes to Jeff Butler. He's the creator of plugboats.com. And I encourage everyone to please check out plugboats.com. But of course, after this webinar, please. But yeah, I really think it'd be a great experience for you to see this new website resource. And Jeff's work has truly broadened awareness, and I applaud his efforts. And quite frankly, it has much more informative information and than the brief history I'm about to share with you. So please do visit them after this webinar. Okay. As aforementioned, my introduction to electric propulsion was electric boats. And if we all take a closer look at this slide, I think you'll see that the premier electric propulsion equipment is made up of golf cart components. And if you zoom in on that motor, you'll see that saltwater and golf cart motors don't go too well together. So these 4 to 5 knot fiberglass wooden floating golf carts were what you bought back in the day, and you know, until repower options and existing for existing boats began to take hold. Okay, in 1974, Ray Electric outboards, they slowly entered the market, yet my introduction to them wasn't until 2007 via Todd Sims of Torqeedo. Thank you, Todd. But again, if we look closely, the motor components are, again, golf cart motor, controller, and also I have a little video here to show you how they don't sound as quiet as golf carts. And then there was Torqeedo, thank goodness. So from their debut in 2005 with their Travel 401 to their engineering advancements to become a full production electric boat manufacturer, that truly changed everything. And we're all grateful. Torqeedo spent millions to commercialize, mass produce, and rightfully gain the market share in the electric motor industry. Okay, in addition to their state-of-the-art lithium-based marine batteries that easily surpasses lead acid, which is all we had back in my day, in performance, charging capability, and safety measures. So again, another wonderful advancement. Along with their development of their sail drive and inboard motors, they also have a fixed pod that I don't have pictured, sorry, but coupled with the BMW i3 and i8, high density lithium batteries, Torqeedo became the industry leader in recreational and commercial applications. And I gotta pop on here real quick because I take my hat off to them. Okay, and I love this slide. I think that truly shows the technology together. So around the same time frame as Torqeedo, a small Austrian company began production as well. Pictronic offers really high voltage inboard electric motor systems up to 180 kilowatts. However, most notably, I appreciate their unique and robust 48-volt steerable pods that range from 1.5 to 10 kilowatts. And and their motors, they're direct drive. They have direct drive components that make them silent motors. Pictronic, the 6.5 and the 10 kilowatt were the pods that I chose to upgrade my Island Packet branded 24-foot launches. And today, Yanmar Mastry offers Pictronic the versatility of that to repower for our repower projects. These motors, they become the prop, shaft, and the rudder replacement for really, truly improving the vessel's maneuverability. So a nice, unique motor alternative. So now introducing a relative newcomer, but a company that's gaining market share with their quality and their competitive pricing. What I admire about e-propulsion is their focus. What they did is they studied like most electric and combustion engine manufacturers. They dissect others, and they focused on what they can improve on the Torqeedo travel and cruise models. So e-propulsion, they manufacture a direct drive that basically is silent compared to the gear ratio in a Torqeedo motor that produces a little bit of a whining noise. However, that led Torqeedo to manufacture their own direct drive and therefore, in my opinion, I think competition is a good thing. So also to note that the Propulsion Navy's 6.5 kilowatt, it's a 6 kilowatt motor, is not an underwater direct drive pod motor technology, but rather it's a motor component. All the components are located on the upper part of the motor. But I have a news flash. E-Propulsion will be soon releasing a Navy 6.0 direct drive motor so that customers can have the advantage of choosing what format they prefer. Okay, so now let's go to E-Propulsion also offers their line of lithium-based batteries. These batteries are, they're different chemistry. They weigh more than Torqeedo, and they're, different chemistry, way more, but they have a higher wattage and they're at a more competitive price. But yet both brands, their quality marine lithium batteries, they've made safety the #1 priority. And I think we're all very grateful for that. Okay, lastly, I want to touch base on 2 inboard electric motors. One, it's a US company called Electric Yacht, and the other is a European company called VETUS. And I think this is the perfect segue into Chris's presentation that I feel is, better quality direct drive inboard motor solutions. So as you see, these motors, the Electric Yacht it's a brushless AC motor, while VETUS is a brushed DC motor. So, but both have pulleys and belts which produce, a bit of noise, but also the fact that, that these belts, in my opinion, are a weak link, as this propulsion system is your main component for propelling your boat. So I, again, prefer direct drive. And then I'm also all about, silence. I know that my Island Packet launch, when I left the dock, people turned and looked at each other and said, how are we moving? Because you could not hear a thing. And of course, the low maintenance of electric boats, which I'm happy to report, they are becoming the new wave of electric propulsion technology. And thank goodness for this ever advancing technology. Let's take a look at these 3 sides and compare what it was in the past to what we have now today. So that, let me get back on screen here. So that ends my presentation and a brief history again. And I will be available at the end to discuss anything you would like to ask me. And I'm sure a lot of people are going to ask me about that wooden Ferrari boat, which I'm very proud to have repowered. So I will leave you now and let Chris DeBoy take over.
All right, Chris, you should be taking control there.
Thank you, David. Okay, David, can you see my screen?
Yep, we're good.
Okay, great. First off, David and the ABYC team, thank you all very much for allowing us to present today. I find that, these lunchtime webinars have been very informative over, you've been pretty much doing them for, since I think March, April timeframe, and I think it's very beneficial to, keep in touch with everyone and get the information out there. I also would like to thank Nancy, my co-presenter here today. I'm Chris DeBoy. I'm with VETUS MAXWELL, and I've been with VETUS MAXWELL for going on 14 years now. And so I've seen a lot of our products and our different developments over the years. And I'm here to talk about our new line of electric propulsion. Obviously, Nancy gave us a little background on a little history and what other products are out there in the marketplace. And so our products fall in line with some of the other products that are available in the industry. And we do have a little bit of a different take on our products, and that's what I'm going to show you all today. So with that, I'll go ahead and get started here. So some of you may or may not know, but back in the 90s, VETUS introduced their first electric propulsion system. It was called the EP2200. It was actually a 2.2 kilowatt brushless drive system. So you see there in the picture that it had a motor connected to a controller up on top there. It had a cooling system, an active cooling system with a pump and a strainer, all DC powered. And this device was sold in different OEMs and aftermarket refits. It was an inboard style setup, so it required a prop shaft and a prop and a rudder and your normal inboard installation. And then we also, as many of you may know or may not know, we have offered diesel engines, diesel propulsion engines for many years. We marinize different manufacturers' blocks. For instance, we offer Mitsubishi, Hyundai. We have some Deutz engines, and we actually marinize those engines for marine applications. We don't sell them here in the U.S. due to EPA regulations, but we sell a lot of engines in Europe and around the world and other places. So one of the things that they did do when we introduced the EP2200 electric propulsion is they created a hybrid propulsion drive setup. So they had the prop shaft or the motor shaft, the main motor shaft coming through the motor, as you see, and they were able to connect it up to you see the picture in the bottom right there. This was one of our small 2-cylinder 12-horse diesel Mitsubishi-based engines connected to a mechanical gearbox, and it was just a matter of placing the gearbox in neutral, running the electric propulsion device. When the batteries were drained, you can fire up the diesel and get home. So we had this product introduced in the 90s, and then we discontinued it probably around the same time I came on board with VETUS, which was around that 2005, 2007 range. So and then what we did is we focused on other projects. A lot of people, when they hear the name VETUS, they think of VETUS thrusters. So around 2010, we started work on our product that we call our rim drive thruster, which was a permanent magnet brushless motor thruster. It's a unique design in that it's a cast aluminum housing, and we actually have the rotor or the propeller has the rare earth magnets epoxied into it. So this is the whole motor design, the housing and the propeller all in one. And the unique features of this product, it has one moving part in it. There's one bearing on the main shaft there. So it is extremely quiet, and because the unit is completely submerged in water and it's constantly cooling itself, it's actually a continuous runtime type of device. We introduced it as a thruster. It is a 48-volt power supply, is required to run it. So we've had some success selling it as a bow thruster. And one of the components of this product was the motor controller that we designed. And because the design is basically an AC style motor, a 3-phase AC motor, we had to design a motor controller that would allow us to take in the DC from the batteries and then convert that to AC output to the motor to make it control. So we created our MCV motor controller, and it was able to take in 48 volts DC, convert that to a low voltage AC output, and it gave us a lot of control over the thruster. I mean, it's completely proportional, and it's a true proportional. So we have a true range of speed from 0 to 100% proportional. It's using obviously lower current draws on the DC supply, being that it's 48 volts. The design was, very low maintenance, no mechanical switching because everything's electronic. So it's a sensorless design. So there's no sensors for failures or anything like that. We're constantly monitoring the motor and the controller temperatures. We're monitoring the RPMs and the voltage. And then we decided that, hey, there's a lot of functionality in this motor controller. Well, we went ahead and we upgraded the motor controller and we added a charging function directly into the motor controller. So not only does this motor controller run the thruster and it tells it, to start up and thrust to port or starboard and how much thrust to provide, but there's a third battery connection on the motor controller that we can actually connect to a separate DC source. And it'll take that DC source in and convert it to the 48 volts and output it back to the supply bank and charge the supply bank. So it actually acts as a charge relay sensing that line and looking for the right voltage to turn on, and then it takes the DC voltage in and converts it to the 48 volts for output. For this application, for instance, it would take in 24 volts from like a start battery bank, for instance, and it would actually take that 24 volts in and convert it up to 48 volts and then charge back into the supply bank of the thruster. And this is very unique. We actually received a patent on our motor controller design because of these features. So we actually, not only did we provide the true proportional control of the thruster, but we also provided a charging function, included as a standard feature of the product, because a lot of people looking at 48 volts, there's not many 48 volt chargers out on the marketplace. How do I keep this charged when the boat's underway? And we took away all those worries by providing this feature built into the unit. So once we created this motor controller and had success with the rim drive, we looked at other opportunities for the motor controller. So we introduced in 2018 our Bow Pro line, which uses the motor controller in a more traditional style bow thruster. And the reason I'm giving my background here is because this leads into what we're introducing in the first quarter of 2021, which is actually our E-line or E-Propulsion, electric propulsion line of products. So we introduced the Bow Pro thrusters in 2018 using the motor controller from the rim drive and all the features and benefits it gave us there in a more traditional bow thruster package. And then once we started getting that product out and doing some testing and looking at all the capabilities of the product, we realized that, this product, I mean, in our documentation, we'll tell you that the product can run for 10 minutes. A normal bow thruster, a normal brush DC bow thruster, has a runtime usually in the neighborhood of 3 to 4 minutes, and that's for all the different types of brush motor bow thrusters in the marketplace. That's what we usually state as our standard runtime on those thrusters, 3 to 4 minutes in an hour, and then it has to cool down because they consume a lot of energy in a short period of time, and they heat up. And they have a thermal breaker in them that will trip and shut the motor down until it cools down. It's a traditional bow thruster is almost the motor on it is almost like similar to a starter motor in a vehicle. So it's going to go ahead and consume a lot of energy, produce a lot of thrust, and then it's going to heat up because that energy has to go somewhere. So with the induction style or the Bow Pro, where we're taking DC in and we're actually converting that to AC out, a low voltage AC out, and running it, we with the new design and the different testing and running functionality of that product, I mean, we actually state that our Bow Pro line can run for 10 minutes. But in reality, when we actually put them into real life applications and doing the testing, we're finding that the motors can almost run unlimited. Obviously, it's limited by the battery bank. But the fact that we're actually including the charge feature into the motor controller also even gives it an even longer runtime, because not only are we able to produce the thrust by pulling the energy out of the battery bank, but we're also putting some of that energy back in through the charge feature. So for instance, on the 48 volt thrusters, we're actually, normally when you're using a thruster, you're using the thruster with the engines running. So if the charge connection is connected to the start batteries, it's the start batteries are being charged by the alternator, and it's going to allow that voltage to be put back in. So we saw that we had very long run times with this new product. So that's when we realized that we could have another use for these thruster designs using the motor controller, and that could be for electrical propulsion. So as you see on the screen, we have a E-line 50, 75, and 100, which equates to basically a 5 kilowatt, 7.5 kilowatt, and a 10 kilowatt inboard electric propulsion style device. Some of the unique features of this product is that it is an inboard design, and it's a complete package, as you see there on the screen. So we have the motor controller mounted on top of the motor there with the cover, and all of our connections, our battery connections, our control connections are all right there as one drop-in device. We've also designed the mounting so that it matches up for like our small diesels. You know, I showed you the picture earlier of the small diesel engines that we had installed, and the actual mounting feet on this product line is designed to use the same stringer setup as it would on an inboard. So whether it's an OEM building a new boat or if it's a refit where you're actually pulling a diesel out and putting in electric propulsion, we've tried to make it as simple as possible to get this installed from that perspective. So we also have active cooling on there, which I'll show you here in a second. So this is a quick shot of the battery connections under the cover. We have our main battery connections coming in, our positive negative cable, and then we have that third smaller line coming in as our charge port. So with this motor controller, we're able to take in 24 volts up to 80 amps, and we're able to charge back the supply bank at 48 volts up to 40 amps. And obviously an electric propulsion boat, we don't have that source while the electric propulsion is running, but when you get back to the dock and you plug it into shore power, that's where this feature will come into play. We're going to offer all of the different models with an option of keel cooling or of raw water cooling, depending on what works best in your environment. And then and that's going to be a complete package with a pump and a strainer and all the fittings that are available there. So I mentioned the rim drive earlier. So one of the other items that we've also been able to introduce with our electric propulsion line is our new E-Pod, which is based around our rim drive product. You know, as I mentioned with the rim drive, it was a breakthrough for us when we designed the product. There has been other applications of this design and used in you know, there are commercial environment applications for this design and different things. So, you know, we said, well, let's go ahead and look at using this as a propulsion device also. Since it has all the features of the unlimited runtime, it's extremely quiet. It's much more efficient than a lot of devices because of the design. You know, and the fact that, you know, when you install this as a pod into a boat, the top picture there on the right, you see that's all that is required of space inside the boat for the motor package. You know, so you have the motor controller there on top with the 3 wires coming in for the battery connections, your main and power and ground, and then you also have that third connection as a charging connection. And you know, but what we're providing here in this pod is with our conventional inboard, you still require a shaft log. You're going to have some type of shaft seal. You're going to have the shaft and the prop and all of those devices in there to make that inboard propulsion device operate. With this package, the builder just needs a hole in the bottom of the hull, bolt it in, wire it up, and you're done. We've taken away the need of the shaft log, the propeller, all that. We've given you all that in one package. And by the way, it's extremely quiet and extremely efficient. Now, it is a fixed pod design, so you still need a rudder. But the product is very simple. It makes it very easy from a boat builder installation aspect, and it can be done on a retrofit. It just, you know, might require a little more work in a retro application. So the actual products, the E-line and the E-Pod, we've actually spent the last 2 years and over 2,000 hours of testing in 2 different boats, one of them with an E-line and one of them with an E-Pod. Our engineers have done a lot of testing over in Europe. Obviously, our company, our corporate headquarters is based over in the Netherlands. We're just outside of Rotterdam, and you know, the main boating over there is a lot of inland canals, and they have open boats, which they call sloops. And these open boats usually have small diesels in them. So it made it very easy for us to look at, okay, what can we offer from an electric propulsion package to be able to provide into these canal boats. And so it was very easy for us to, you know, find the type of boat that would work for these packages, as well as, you know, do the testing right there near our headquarters. So we look at the package that we will be offering in 5 different modules. So we actually have our you know, different E-drive propulsion. Is it going to be E-line? Is it going to be E-Pod? And then we go ahead and look at, you know, the control. What type of controls are we going to have there for the propulsion? Monitoring, how are we going to monitor it? Battery solution, what do we offer for battery solutions? So we have AGM available currently, and we're in the process of introducing our lithium solution. And then our shore power charging options. So we're looking at trying to provide a complete package. So when we sell this to a builder or a refit yard, we want to be able to provide the complete package, and rather than having to go out and source other components. Now, obviously, depending on, the builder or the refit yard, they have the option to use other battery solutions. We're going to learn about, about the Master Volt lithium solution here next month, and that might be a solution to power these also. So our scope of supply basically is, I'll show you some part numbers here. We have the first line there is the actual E-line, propulsion motor device, and then we're going to supply a key switch in the solution, and that actually gives us the capability of, securing the system so nobody can use it with the key switch. It's also going to power up our VCAN communication line. So we have our own CAN communication between the different propulsion devices and the controls and the monitoring. So we have our control lever there that you see. It's a side mount style control, and then we have our VCAN cables and hub and a normal requirement for a CAN interface there. We also look at the monitoring panel. So there you see a LED monitoring panel. This is a very simple design. It's going to give you basic information as far as battery, temperature warnings, different warnings there. So it's just a very simple design. But we also have what we call our CANverter. And this is really what we feel is a big benefit, is that, we have a VCAN to NEMA 2000 converter. And obviously NEMA just announced the launch of version 1 of OneNet today. So that'll be able to transfer that over to the OneNet also. But we're going to be able to output all the information to a NEMA 2000 device using our CANverter, which we think a lot of people will, have a multifunction display on the boat and be able to display that information right on there. So that will be very beneficial. Batteries, currently we have our AGM solution, and then we'll be introducing our lithium solution. And then as far as chargers, we currently have our chargers in Europe. We sell generators, so that's a solution. Solar, short power cables and plugs. So we will be able to provide a full scope of supply there with the package. Quick snapshot of our VCAN converter. The type of messages we'll be able to translate there is the motor engaged, motor RPM, voltage, current. So all the information that an operator would want to be able to see on the screen there, we will have that available. So our engineers have been working on the technical committee with NEMA to be able to add in electric propulsion into the NEMA 2000 suite. So this will be very nice to have that done. So we're looking forward to that. We feel a lot of people will kind of like that option as opposed to some type of proprietary monitoring system. Real quick schematic on that charging, so I was talking about that. So with our inboard propulsion here running at 48 volts, if we use a 24 volt house bank, so the house bank could be used for lighting, for entertainment, maybe refrigeration. So there's a lot of different sources there for the 24 volt house bank, and we don't want to really use that for our supply bank to the motor. So we can actually have that 24 volt house bank, and we can have a short power charger, or we could have a generator on board, and we can go ahead and once we plug in or fire up the generator, we could be charging that 24 volt bank, and that third connection on the motor controller will see the charge voltage coming in to the motor controller, and it'll go ahead and turn on the relay to allow the charging function to take place, and it'll go ahead and take the 24 volts in and convert that up to 48 volts and go ahead and charge the supply bank. So this is a schematic here of how that could be utilized for this. Again, we can take in 24 volts up to 80 amps and then output 48 volts up to 40 amps. And then we also offer a line of 48 volt thrusters and 48 volt windlasses to be able to utilize that supply bank for those other large consumers of energy. So we again, we're looking at, being able to provide a complete solution for a customer there. As we see, there's to really be in this market, you have to be able to supply the complete package. I mean, Torqeedo and some of the other manufacturers are supplying the batteries, and they're supplying all the control system and the battery management systems, and we really feel that's needed, and that's what customers are looking for. And that's what I have for my presentation on what VETUS will be offering. And like I said, we should have product in the U.S. in first quarter of 2021. Thank you very much for your time here this afternoon. And David, I'm going to go ahead and switch it back over to you.
Sure. Well, thanks again, guys. Really appreciate that. And I think it was as our first time here talking about electric propulsion. We covered a lot of information. And there's a bunch of questions that are coming in here, so let's get rolling with those. I'm going to grab this from you. Yeah, if you have any questions, we're just taking them in the question box, so we don't have enough time to count on all the raised hands. So definitely type it in there, and we'll get to them. So let's start with, I have an atomic sailboat with a universal atomic 4 gasoline engine. Can it be retrofitted with a battery bank, solar panel, and electric propulsion unit equal to the existing 30 horsepower unit? Would it be cost prohibitive? And I just want to add on to that because there's been a few of these questions. With that, what are kind of the selling points to switching from regular combustion or compression engine to that? So kind of a two-part question to cover about 3 or 4 more questions that were asked.
Well, what size is the boat? It's
41-foot sailboat specifically is what
41.
we're talking about.
Okay. Yeah, 41, you're probably in the range of a 20 kilowatt repower necessary for that boat. But it can be done. There are several options. I know, well, the VETUS that Chris was just referring to it's not, the 10 is the largest, right, Chris?
Yes, currently 10 is largest.
Yes. I'm going to share. I'm working with a Canadian company called Electromax, and we're designing a like a 10 to 20, 20 to 30, 30 to 40 range inboard solution. And we're hoping to start doing testing on that in January. So yes, it can be done, is my answer. And I forgot the second part, sorry.
Just what are the selling points? Say, the common question I'm bringing into one question is, how do you bring this up, or what are some of the key selling points of switching over from diesel to, say, electric?
Oh, very simple. I would say, first off, no fumes. Your salon is nice and doesn't smell like diesel. But no, low maintenance. You have a regenerative. As you're sailing, you can regenerate your battery bank. I'd say, there's just a lot of advantages. But number one, I just like electric propulsion is reliable, and I like the fact that you don't have to worry about maintaining it.
All right, next question. Is there a chart that exists that kind of compares apples to apples of horsepower versus, whatever the kilowattage is? Is there a chart for that is accessible for people?
What we do, and what I'm planning to do with Electromax is we're going to have a projection model. It's going to be called a propulsion projection model. And you're going to be able to put in your specifications and the type of sailor or the boater you are. And it's going to give you a feed out of what they suggest, that you can install. So as a chart, it's difficult because if you compare a kilowatt to horsepower, it's not as relative, and there's some torque in there, and there's more power. For instance, like the Cruise 10.0, Torqeedo Cruise 10.0 outboard. It's, it's a 10 kilowatt, but it's really rated at 20 horsepower. So if you did the math, it would be around 14 horsepower. So, it differs is what the answer is.
Yeah, and David, if I can just add to that, so
Yeah.
I mean, our solution that we will be introducing here, we're mainly focused on displacement hull vessels. We're not looking at planing hulls or semi-planing hulls. We're focusing on displacement hull vessels, and we have been working on a application that we'll launch on our website to allow the customer to put in some information as far as the length and the beam of their vessels at the waterline and the style of the hull, and give some projections of what is the hull speed and how much power is required to get the hull speed, and that's all pretty standard formulas, so we can kind of give customers an idea. I mean, obviously there's so many variables as far as conditions and growth on the hulls and just different things that go into that. So we will give a range basically of you should need this much kilowatts to move the boat at hull speed, things like that.
All right. So my takeaway to kind of circle on that whole question is there isn't necessarily a solution that says, hey, a 40 horsepower engine, I can replace it with this. There's more that goes into it. So you need to talk to the manufacturer, whoever that may be, to help you size that. Does that sound correct? Okay, that's good to know, because I think that was a question that was asked a lot, and I was curious on that one too. So question for Nancy, can you discuss Ocean Volt systems, all electric propulsion and hybrid, in context to other systems you've described?
I have not had experience with Ocean Volt. I'm sorry to say, I've not installed one. But the research shows, I mean, they seem to be, it's a good quality motor system. I see that they like to incorporate all of their components, the motor, the batteries, the chargers, the controller. It's all a one package product. So that has an advantage. But I'm sorry, I'm not going to be able to address personally Ocean Volt's quality.
Right. What is the maximum voltage of the VETUS 48 volt system? Can it tolerate a 58 volt absorption voltage if the battery pack is directly charged at a 48 volt generating source?
So off the top of my head, I believe those figures are on the high side, because obviously the motor controller has different parameters of in-range parameters, so to speak. So, and it's really, the charging is designed currently around our battery solutions which is flooded lead acid and AGM solutions, so that charge profiles are currently set for those. So it sounds like that voltage might be a little high and a little bit out of range from what our standard settings would be. But we do have, like I said, we are introducing a lithium option as a scope of our supply, and we will be updating the motor controllers to be able to charge back into lithium with the higher voltage ratings.
Right. What are the concerns with corrosion and anti-fouling with electric propulsion versus standard?
Well, I mean, the components are marine grade, meaning corrosion in the the motor itself. Is that what I'm understanding?
Yeah, I think potentially with an electric pod or something like that, is the components are different since it's not on a full shaft and things like that. And so what is there to prevent that? And is there any other additional concerns there?
I've had my Pictronic, there's anodes are applied in several locations, but I've had those underwater for 6+ years now, and not a problem. I can speak to that. I can speak to, the inboard solutions, of course, are no brainer. It's just the shaft and propeller. But I think that it's, they're being built to be for salt water and underwater, purposes. So manufacturers are taking that into consideration.
And so, David, I can just speak a little bit about our solution. Obviously, a lot of the boats built in the Netherlands is aluminum. It's a large majority of boats over there are built with aluminum. So that's obviously one of the items that we have to take into consideration is looking at aluminum, aluminum hull boat with electric propulsion. So our inboard solution obviously is using engine mounts or isolators. So there is no direct metal connection between the actual hull or stringers and the propulsion motor. So we do have that separated there. Also, from a cooling capacity there on the inboard propulsion, we have the keel cooling option. So from that standpoint, you have a closed cooling solution with the keel cooling. So there is no need to have any raw water intake if you didn't want that. If you're on a freshwater lake, it may not be concerned, but if you're in a high salt environment, the keel cooling option might be the way to go. And then as far as our ePod device, when that's installed, there's a heavy gasket or seal that goes in between the actual mounting surface or the hull if it was an aluminum vessel. So we are isolating the actual motor devices from the hulls, and the only electrical connection is obviously the batteries.
All right, I got a few questions here on lithium ion. Guys, tune in next month. We got a whole presentation just on that. So those questions about safety we can address then. When do you guys think we will see system size for planing hull boats, maybe in the 150 to 200 horsepower range?
They're there now. There's, like as I mentioned earlier, Pictronic, they offer, but granted, they're very high voltage systems. The Torqeedo is the same. I mean, there's the 180 kilowatt, 100 kilowatts. I'm working on several projects for displacement hulls for planing hulls. And so, and one's locally here in St. Petersburg. So I'm really anxious to work with them and get results and be able to share more with you. And I probably could share it on plugboats.com as well, because again, it's an excellent source.
All right, and I think we had time for one question or so. What are some of the expectations and differences when you're talking about charging systems? People are used to fueling up their gas tank and going. So what are some of the things when it comes to charging that need to be taken into consideration that are going to be different from a combustion engine?
I'll take it, Chris. Well, I am seeing that chargers are becoming higher amp alternatives. I mean, Torqeedo has now I believe a 50 amp at 120 voltage. Of course, 240 voltage is like the best for faster charging. But we're realizing that people want, I mean, I drive an electric vehicle and I want to be able to fast charge where, when I'm doing a trip. And so that's they're looking for for electric propulsion as well. So I think the smart chargers are matching the battery technology. It's a combined effort.
All right. So with that, I think that wraps it up. And for everybody questions we didn't get to, this won't be the last time we talk about electric propulsion. I think we're just skimming the surface here. There's plenty other topics. This is our intro one. So, if you want to see more, have more specific questions, let me know. I want to thank Nancy and Chris for coming out today. Really appreciate it. I know everyone's busy, getting ready for the holidays here. If you're looking for CEUs, once again, if you're watching it live, you will get an email tomorrow with a follow-up, which has the link to apply for those CEUs. And if you're watching this on YouTube, you will see a link pop up somewhere on the screen. Matt always puts it somewhere different to mess with me. So you will see it pop up on the screen at some point. on the YouTube there. So once again, thanks everyone for showing up. I hope you guys have a happy and healthy holiday season, and we will pick this up in January. So thanks again, everybody, and we will talk to you soon.
Yes.
Thanks very much. Happy holidays.
It was a pleasure. Thank you. Sorry for my technical difficulties.
Take care.